Number 4 on the 2016 exam, consider the differential equation dy dx is x squared minus half y. Part A, find the second derivative with respect to x in terms of x and y. So we got to implicitly differentiate this. So d squared y over dx squared is equal to power rule 2x minus half dy dx. Okay? And what's dy dx? They give it to us right there. So plug that in, box your answer. As simple as that. Okay? Part B, let y equals f of x be the particular solution to the differential equation whose graph passes through the point minus 2, 8. Does the graph of f have a relative min, relative max, or neither at the point minus 2, 8? Justify your answer. This is a very typical conceptual question on using the first and the second derivative to determine max min. Okay? Let's understand how this works. So remember, there's a chance for a max or min to occur if the first derivative is 0, okay? It will occur if the first derivative changes sign. So either it goes from negative to positive, which means there's a min, or positive to negative, which is a max. But we don't know what happens around this point. We only know what happens exactly at this point. So we can't really use that changing sign thing to help us out here. That's why we have to use the second derivative as well. So if this is equal to 0, then, as I said, there's a chance for there to be a max min. We don't know anything that happens before or after, so we can't determine if it changed sign or not, if it crossed 0 from one side to another or not. So we use the second derivative. If the second derivative is negative, that means it's concave down. If it's concave down, what does that mean? Look at what my finger is drawing. That means there's a max there. If it's concave up, which means the second derivative is positive, there's a min there, okay? If the second derivative is also 0, then it's a point of inflection, so you can't really determine max min there. You would have to actually figure out what's happening around here, the first derivative, okay? So that's the concepts that we have to use here. This appears quite often on the AP exam, whether in the multiple choice or on the free response, okay? So we evaluate the first derivative at minus 2, 8. Plug in x is minus 2, y is 8 into here. You'll get that it's 0, which is what we are expecting, okay? So there's a chance for there to be a max min there, so let's confirm with the second derivative, which we found up here. Plug in minus 2, 8, okay? By the way, this value is right there, so it's minus half times 0, so this whole term goes away, so it's minus 4, okay? So since it's concave down, the second derivative is negative, that means it's concave down. Y is concave down. Okay, so our justification is since dy dx is 0 and d squared y over dx squared is negative at minus 2, 8, that means there's a relative max there. That's a good enough justification to get all the points. Okay, you have to show that first derivative is 0, second derivative is negative. Okay. Part C, this is a weird one, but you could probably imagine what's going on if you're a good test taker. Let y equals g of x be the particular solution to the given differential equation with g of minus 1 equals 2. Find this limit, show the work that leads to your answer. Okay, so this is an AP Calc BC, right? So probably need L'Hopital's rule here. Let's confirm. We always want to plug in first, no matter what limit. So when we plug in x is minus 1, we get g of minus 1, which is 2. 2 minus 2, which is 0, so 0 on top. And then we plug in minus 1 on the bottom. It's 0 on the bottom as well. 0 over 0. Indeterminate, we can't use L'Hopital's rule. We can. I don't know if that was not clear. We are allowed to use L'Hopital's rule. So we differentiate the top, which is just g prime of x. We differentiate the bottom. We need the chain rule. Okay? So we try plugging in again. When x is minus 1, what's g prime of minus 1? So g is our y, so we need to use this guy. So we plug in x is minus 1, y is 2 into there. Okay, so we get that g prime of minus 1 is 0. Okay, so we would have 0 on top. When we plug in minus 1 on the bottom, is 0 as well. 0 over 0 again, so that means we can use L'Hopital's rule again. Okay, so we differentiate the top again. So it's g double prime. Differentiate the bottom, it's just 6. Now let's check again. Plug in, so what's g double prime of negative 1? That's minus 2. So minus 2 over 6, that's not 0 over 0 anymore. we take it as is. So that's minus 1/3. You don't need to simplify. You could just box that, but this one's simple enough, so I simplified it. Okay. Again, if you're a smart test taker, you could probably have guessed that this is probably L'Hopital's rule. Some weird thing that they're asking. Okay. Part D, let y equals f of x be the particular solution to the given differential equation with h of 0 equals 2. Use Euler's method, starting at x is equal to 0, with 2 steps of equal size to approximate h of 1. This is very typical Euler's method problem, so let's go through it. We start at h of 0 equals 2. We want 2 steps of equal size, so we're stopping at 1, we're starting at 0, so 1 minus 0 over 2, our step size is half. So the next point is 0 plus half, which is half. Okay, it's approximately equal to, be careful to actually write approximately equal to. Don't write equal signs because sometimes they mark off, okay? It's approximately equal to h of 0 plus h prime of 0 times 0.5. h of 0 is 2. What's h prime of 0? Plug in x is 0, y is 2. So you get minus 1, right? So you get 2 minus half, which is 1.5, okay? And now, next step, so 0.5 plus the step size, 0.5, which is 1, okay? So, h of 0.5 plus h prime of 0.5 times 0.5. h of 0.5 we found is approximately 1.5. h prime of 0.5, so we plug in x is 0.5, y is 1.5 into there. That's why I did there. And times another 0.5, don't forget that. Okay, so I would just box this, honestly, too risky to simplify. Okay? They should accept this. But just to check that I did get the correct answer, I simplified. It was 1.25, which is, in the scoring guidelines, they said 5/4. It's the same as 5/4. Okay, so again, this is way too risky to simplify, so just box the answer from here. Okay? All right, that's it. Hopefully this was helpful. I think this was a pretty good practice question. Lots of typical ones, like Euler's method, second derivative, and part B is a very typical question even for AP Calc AB. Okay? This one is definitely a BC topic, or I really don't remember if AP Calc AB learns L'Hopital's rule, but this is for sure. Since it's such a weird question, it's probably L'Hopital's rule. That's one of the topics that you learn in this class, right? So, good guess would have probably been to use that even if you were completely clueless. All right. Please give this video a like if you found it helpful in any way, and hopefully I'll see you in another video as well. Bye.